Okay, so to start out with Unit 2, bless you, we are talking about decimals. To understand decimals, we have to understand our place values. So let's go back and review our place values in front of the decimal points, our whole number place values first. So starting at the end of the number and working our way backwards, the first one here is the ones, and I'm going to write them out numerically today. The tens and the hundreds, then the 1,000s, the 10,000s, and the 100,000s. Now as we look at these, if we start at any place value and move one place value to the right, the numerical value of that place value is divided by 10. So we take off a 0 or we divide by 10. If I go from 1,000 to 100, it's dividing by 10. From 100 to 10, it's dividing by 10, and so on. So if we keep going past the decimal point to the other side, keep going to the right, if I move one digit to the right, I have to divide by 10. Well, 1 divided by 10 is 1/10. Divide by 10 again, that's 1/100th. 1,000th. 1/10,000th, and so on. Now you might be looking at those place values and thinking, they look suspiciously like fractions, because that's what they are. They're nothing more than a shortcut way of writing fractions that have denominators that are powers of 10. If I have 0.64, that's really a shortcut way of writing a fraction. What it is you have the 6 and the 4. The denominator of that fraction is the place value of that last digit. So the 4 is in the hundredths place, right? So that's 64 out of 100. So 0.64 is just a shortcut for writing the fraction 64 hundredths. Now that's not, it is a fraction that's equivalent to 0.64, but we wouldn't want to leave it that way. If we were going to express this as a fraction, what would we normally do with it? Reduce it, simplify it. Both of those can be divided by 4, which would give us 16/25. Make sense? Kind of, sort of? Okay. So 0.375, how would I turn that into a fraction? I put the 375 over, what's my denominator going to be? Thousandths, perfect. This is tenths, hundredths, thousandths is the place value of that last digit. A little trick, by the way, just to double check, there's 1, 2, 3 decimal places. There has to be 3 zeros in my denominator. So now, of course, this we would want to reduce. Both of those can be divided by what? 5, which is going to give me 75 over 200. And both of those can be divided by 5 or 25. Let's do 25. What the heck? Gives us 3/8. So in your notes, I want you to try to turn 0.5625 into a fraction. So what is that going to be to start out with? 5,625 over 10,000. Did you get that far?
Oh yeah.
Okay. Still reducing it?
Yeah.
Well, what's it divisible by?
Would you give that?
50? No. Doesn't divide by 50. It'll divide by 25. There you go.
You got farther than I got.
So if you divide it by 25, what do you get?
125 or 400 over 400.
Okay, 225 over 400. Now it's divisible by
25 again.
25 again, yes.
That's why I said 50.
Yeah, you can't add them, they have to multiply. 25 times 25 would be 625. So they both would have been divisible by 625. So 225 divided by 25 is 9. 400 divided by 25 is 16. Does that make sense at all?
It makes more sense than
Well,
what it did.
yeah.
Please don't ever make us do a problem.
So 9/16. Don't make you do a problem like that. That was not so bad.
It's too much thinking. It's too early.
How about something that looks like this? How do we handle the 3 here in front of the decimal point? Yeah, it's the whole number. Sometimes this is what we even call a mixed decimal. Kind of like mixed numbers with fractions where you have the whole number and then the fraction. The 3 here is just the whole number, and we're going to have the fraction after it. So we just have to take the 842 over what? 1,000. And we're going to reduce it. Both of those can be divided by how much? 2. Okay, good job. So this is 421 over 500. Can either of those be, can that be reduced by anything?
Probably. No.
If you have a fraction calculator, you can do 421 ABC 500 and hit equals, and it shouldn't reduce it. You've got a fraction calculator. Go ahead and punch it in.
Yep.
It leaves it?
Wait. Oh.
What did it do?
Oh, I typed it wrong.
Okay, try it again. We'll wait, because I mean, there might be something odd, like a 7 or an 11 or something. No, 11 don't work, but maybe like a 7 or 17 or 13 or something weird like that. I don't think so, but it is 421 over 500. Because I thought 500 is really only divisible by 5s and 2s. So there it is, 3 and 421 over 500. So you just have to leave the whole number. The biggest mistake I'll see people make is they'll leave off the whole number after they create the fraction. I'll have you guys try one of your notes. Turn that into a fraction, a mixed fraction, a mixed number. Do you need a minute yet, or you give up? Okay. So you've got the 8 is the whole number. Now we got to look at the fraction. So it's the part after the decimal point that's going to become part of a fraction. What's that going to be as a fraction before we reduce it? 625 over 10,000, both of which can be divided by... Not 625, no. 25 though will work. There's one larger number, but I'll show you that in a second. So that's going to be 25 over 400. It does work, doesn't it? Never mind. Okay. Sorry. It does work, you're right. So you divide by 25 again, would have been 625 in the first case. It's early. Some days the hamster doesn't get all the way on the wheel.
Now you know how I feel.
So that's 1/16? Okay, so 8 and 1/16. How many of you had that 8 and 1/16? Cool. Anybody have no clue how to get to it? Once? Anybody want to see more examples? Okay. Well, next on the list. To convert from fractions back into decimals, we have to use that idea that fractions are a division problem. So 3/4, obviously we know what that is as a decimal, but if we didn't, the conversion would be 3 divided by 4, gives us 0.75. We need to talk about our operations with decimals first, and then we'll come back to that, converting a fraction into a decimal. So let's look at our operations. Something like this, if we're adding 2 decimals, what do we have to make sure we do as we set the problem up? Line up what? The decimal points. Can anybody tell me why we line up the decimal points? Place values. We talked about when we add or subtract, we can only combine things with the same name, which means the place values. The names are for our whole numbers, and for our decimals is the place value of the digits. Lining up the decimal points, make sure I'm combining tenths with other tenths. and 1s with other 1s, and so on. Now, before I add these, if there are any differences after the decimal point, I fill in those missing spots with zeros. For addition, it isn't that important. I can get away without, but it's a good form to get in the habit of. So 3 plus 0 is 3. 7 plus 8 is 15. I have 5. Does the decimal point affect me carrying it? No, not at all. But before I can add the next column, I need to make sure I do what? Bring the decimal point down. I don't want to cross the decimal point without doing something with it. The only exception is multiplication, and we'll look at that. So now I've got 1 and 8 is 9, plus 4 is 13, so that's 3 carry the 1, and 1 and 1 is 2. So 23.53. Bringing that decimal point down, remember we said when we add or subtract, we keep the same name. So bringing it straight down made sure that the tenths stayed tenths, the hundredths stayed hundredths, the ones stayed ones, and so on. So the way we handle our decimal when we're adding decimals and subtracting, we line them up because when we add or subtract, we must have the same name. This is, of course, when we add or subtract. So for decimals, that amounts to lining up decimal points. And when we add or subtract, we keep the same name. That is just bringing down the decimal point. Subtraction is pretty much the same way. $32.8 minus 9.47. We make sure we line up that decimal point again. And we make sure we fill in the missing decimal places with zeros. And we subtract. 0 minus 7 can't be done. So just like any whole number, we can borrow from the 8. That's a 7. This is a 10. 10 minus 7 is 3. 7 minus 4 is 3. Now again, the decimal point doesn't affect anything. We could borrow across the decimal point if we needed to. But before we cross it, we have to bring the decimal point straight down. So now 2 minus 9 can't be done. We borrow. This is 2 and 12. 12 minus 9 is 3 and 2. So again, we line up the decimal point because we must have the same name. We bring the decimal point straight down because we have to keep the same name. Now I want to see how you guys handle this one. In your notes, try that one. We'll go over it in just a second, but I want to see how you handle it. So when you set this up, you have to line up the decimal points. The 8 doesn't have a decimal point, though. Where does it go? Right after. If a number doesn't have a decimal point written in it, that decimal point is at the end of the number. So we line that up with our other decimal point. And we do fill in the missing zeros. Now here the problem is when we go to subtract, 0 minus 8, of course, can't be done. So we're going to have to borrow. But we look here, there's nothing to borrow from. So where do we go? All the way to the 8. So we borrow from the 8. That's a 7. That would make this a 10. But we do need it here, but we need to also get it all the way down here. So we have to borrow again. We repeat the borrowing. This is now a 9. And this is a 10. And we go again. Borrowing again, that's a 9, and this is a 10. Borrow again, that's a 9, and that's a 10.
Is it weird that I always thought when you have a number like
You just cross that off and go 9, 9, 9, 9, 10?
No, I change it to 799, 7,999, and I just put the 1.
Oh, 1 in front of 0? Yeah. And that's what a lot of people are taught is just you cross this off, make that a 7, then do 9999, and then the 1 with the 0 or a 10. You don't actually borrow every step. I'm just doing it out like that so you can see that's what's happening. When I go to do it, yeah, I just fill in 9s and then a 10 because I know that's the way it's going to end up. So 10 minus 8 is 2. 9 minus 5 is 4. 9 minus 3 is 6. 9 minus 7 is 2. Bring down the decimal point. 7 minus 2 is 5. How many of you had 5.2642? Good deal. Multiplication is slightly different. So 23.8 times 4.75. When we multiply, do I have to line up the decimal points? No, I don't. Because when I multiply, remember, multiplication and division, number one, we don't need the same name. So that means we don't worry about lining up the decimal points. So we're going to do 5 times 8 is 40, so 0, carry the 4. 5 times 3, 15, plus 4 is 19, so 9, carry the 1. 5 times 2, 10, plus 1, 11, so 1, we carry over the 1. Now, what have we been taught to do down here before we move over to the 7? Put a 0 here. I also am going to put a line up here, so I know that those other carries are old ones. They're below the line, so I'm not going to use them again. So now 7 times 8, 56, right? So 6, carry the 5. Notice I'm putting it above the line. 7 times 3, 21 plus 5, 26, so 6, carry the 2. 7 times 2, 14 plus 2 is 16, so 6, carry over the 1. Now before we go to the 4, what do we have to do? 2 zeros over, because the 4 is 2 spots over from the right. So now we go ahead. 4 times 7 is 32. Or 4 times 8. Yeah, I don't know what it said. 4 times 8 is 32, so 2 carry the 3. Notice I did put another line up here again, so I can put my carries above the line. 4 times 3, 12 plus 3, 15, so 5, carry the 1. 4 times 2, 8 plus 1 is 9. So now I can add my columns. I've got a 0, but I'm going to keep it there because it's going to be important to keep that there. 9 and 6 is 15, so carry the 1. 2, 8, 10, so 0, carry the 1. 1, 2, 8, 13, 3, carry the 1. 11, carry the 1. Where's my decimal point go? Yeah, between the 3 and the 0. Why? Yeah, you're counting the problem. 1, 2, 3 decimal places in the problem. Count from the back. 1, 2, 3 decimal places in our answer. Again, that's because when we multiply and divide, we also combine the names. Counting up those decimal places and combining them is combining the names. Now, you don't necessarily have to count the decimal places. There's another way you could do this. You think of this. This is about 24, right? Or 20 even. This is about 5. 24 times 5 is 120. 20 times 5 would be 100. We're expecting an answer around that 100 to 120 range, right? Would 11.3050 make any sense? No. Would 1130.50 make any sense? No, it won't. This is the only place it makes any sense to put that decimal point. So by doing a little estimating, you can locate your decimal point as well. I'm going to have you guys try one in your notes. Try that one, Craig. You guys need a minute, or are you ready? You good? Okay. So I'm just going to buzz through it. 4 times 2 is 8. 4 times 3 is 12, so 2 carry the 1. 4 times 7 is 28, plus 1 is 29. We'll add our 0, put a line up here. 5 times 2 is 10, so 0 carry the 1. 5 times 3 is 15, plus 1 is 16. 6 carry the 1. 5 times 7 is 35, plus 1 is 36. So 8, 2, 15, carry the 1, 9, and 3. Decimal point goes where? 5 and the 2, 395.28. Very good. Let's look at division. So let's say I have 63.842 divided by 3.7. And I want it to the nearest thousandth. How do I divide decimals? The answer is we don't. We avoid it. So how do we do it? Well, calculator is a good option. Very good. We don't divide by a decimal. We get rid of the decimal in the number we're dividing by. There's one decimal point there, so we move it over one spot, but that means we have to come over here and do the same. We move that one over one spot. This becomes 638.42 divided by 37. Why are we allowed to do that? Well, because I said so, right? Remember, division and fractions are just two different ways of expressing a same thought. So if I look at this, 63.842 over 3.7 is a fraction. If I want to get rid of the decimal point in the denominator, I can multiply or divide both the numerator and denominator by the same thing. To get rid of one decimal place, I multiply by 10. That turns that into 37. I have to multiply the top by 10, which turns that into 638.42. So there it is. If there were two decimal places, what would I have multiplied by? 100 would get rid of two decimal places. Three decimal places, it would be 1,000, and so on. So because of that fraction notation for division, I'm able to do that, to multiply by the same number in each, or move the decimal point in each number. So now I'm going to go ahead and divide just like I normally would. Does 37 go into 6? No, so I leave it blank above the 6. Does 37 go into 63? Yes, it goes in there once. So subtract 37. So that is 26 left over. Can we bring down the 8? Yes, we can. 37 into 268? How many times? 7 times. So 7 times 7 is 49, so 9 carry the 4. 7 times 3 is 21, plus 4 is 25. So that does go. We subtract. We've got 9 there. Can we bring down the 4? Not quite yet. What do we have to do first? We have to move the decimal point up. Just like with addition and subtraction, we cannot cross the decimal point without doing something with it. It's just a matter of moving it to where it's going to belong. So now we can bring down the 4. Does 37 go into 94? How many times? Twice. 37 times 2 would be 74. There's 20 left over. Bring down the 2. 37 into 202. 5 times does it go? Why not? Let's try it. 5 times 7 is 35. 5 carry the 3. 5 times 3 is 15, plus 3 is 18. There's 17 left over. So that works. What's left over has to be smaller than what we're dividing by, is all that matters, right? It can't be negative. Now we're out of decimal places here. Add a 0, good. Add a 0, bring it down. 37 into 170. 4 times. 4 times 37 is 148, correct? We subtract there, we get 22. Are we all done?
For what you want us to do, yeah.
Well, I want the nearest thousandth. That is the thousandth place, but I'm not done. Have to add another 0. And bring that 0 down. 37 into 220 goes 5 times. 5 times 37 is 185. So there are 35 left over. Why did we have to go that extra digit here? Because we need to know if we're rounding the nearest thousandth, the 4's in the thousandths place, is it going to stay 4 or does it have to round up to the next one? And in this case, it has to round up. So it's going to be 17.255. So you always have to go one digit past where you need to round to. Any questions? So now, what if we have that fraction again? Let's do 5/8. And we want to turn it into a decimal. Well, we said it's 5 divided by 8. So to divide that out, we would make it long division. Here's 5 divided by 8. Well, 8 does not go into 5, does it? So we add a decimal point, bring the decimal point up, and we add a 0 here. Does 8 go into 50? Yes. How many times? 6. 6 times 8 is 48. We're left with 2. Now we can add another 0 and bring it down. Does 8 go into 20? Twice. 2 times 8 is 16. That leaves us with 4. Add another 0 and bring it down. 8 into 40? 5 times. 0.625. Not so bad. Now I do realize you guys have calculators. You can just punch it in. But I had to show you. I do want you guys to try, though. 11/16. Divide that out into a decimal. See what you get. So you have 11 divided by 16. 16 doesn't go into 11, so you add a decimal point and a 0. Does 11 or 16 go into 110? How many times? 6. 6 times 16 is 96. Leaves us with 14. Then what? Put another 0. Oops, wrong spot. Put another 0 and bring it down. 16 into 140. 8 times? Which is what? 128. Try to get 12. Add a 0. 16 into 120. 7 times? 7 times 16 is 112. There's 8 left over. Add a 0. Bring it down. 16 into 80. 5 times exactly. 0.6875. How many you got that? Cool. Okay. You guys have suffered enough for one day. In your book, page 63 to 65, it's 1 through 73, the odds. And on page 72 through 75, 1 through 67, the odds. Same as always, if the first few are easy, skip ahead, do some more difficult ones. Make sure you hit, if there's word problems, make sure you hit some of those.